For the military, it opens up a whole new world of weaponry, no longer the stuff of sci-fi. Directed energy weapons will soon be a familiar sight on Royal Navy ships, after the MOD announced it's accelerating its £100 million laser weapons programme and introducing them to the front line in 2027, 5 years ahead of schedule.
Targeting is done very, very accurately. We're looking to target something about the size of a £1 coin, at X kilometres range. Once the pointing and tracking system has locked up that aim point on the target, the laser fires and the laser energy is then focused on that point. And the special thing about laser weapon systems is the ability to then hold that aim point and focus all that energy onto the target. The better you're able to do that, the faster you achieve the effect on the target as well. So you burn through the outer casing, you affect what's inside, and ultimately you achieve the effect on the target that you want.
This was DragonFire in action on a test firing in the Hebrides earlier this year. And this is the damage it can do. On display at DSTL, the military's Technology Research Centre at Porton Down, some of the targets they've tested it on, from melted drones and sheets of steel to 120mm mortar shells, the casing turned to molten metal.
Huge amount of hard work, lots of engineers, lots of DSTL scientists, and we got to the point that we demonstrated the capability. So taking raw electrical power, squeezing it down to create a laser beam, and then critically being able to target it in quite a complex environment. So it's absolutely accurate, and therefore all that power ends up on the target. It's a game changer. This is a revolutionary step in terms of capability.
From Ukraine to the Red Sea, UAVs are an increasing threat in the battle space. Off the coast of Yemen, HMS Diamond and HMS Richmond have both shot down Houthi attack drones using conventional missiles. In the future, though, that could well be a job for DragonFire.
This potentially provides us an opportunity to lower the cost per shot compared to traditional interceptor missiles, which are sophisticated. And that allows us to retain those more sophisticated missiles for the more challenging threats we face. One of the constraints we face is the size of the silo on a ship. That limits the number of missiles that we can carry, whereas a weapon system like LaserDew provides an unlimited intercept opportunity at potentially much lower cost as well.
Research into the military applications of laser technology go back to the 1980s, and of course the UK isn't the only one doing this. This was the US Navy ship USS Portland back in 2020, using a 150 kilowatt laser to take down a drone. The UK has played catch-up, but has now become a world leader in this technology.
The big step change which has enabled us to do this is actually in the laser source itself, where we generate the laser, where we're now getting up to these very high powers, and the techniques to actually enable you to have a very high power and high quality beam, because you need both to defeat a target. And it's how you join create that beam in the first place, and then it comes out through the aperture on the beam director, it reflects off the target, and we use the fire aperture there to actually analyse the return, to play games with or fine-tune that output beam, which now makes it a much more effective and more relevant weapon for the Navy and the Army.
In the years ahead, like all tech, DragonFire is likely to become more compact and enter use with the Army and the RAF. The decision to accelerate delivery, says the MOD, has been made possible by its new, more streamlined procurement model, a system it promises will, in future, deliver weapons like DragonFire to the front line much faster. Simon Newton, Forces News, Porton Down. Thanks for watching. For more from Forces News, like and subscribe to our channel.